we have linked list allocation using table in memory. Let's say we have a file A, which uses disk blocks 4, 7, 2, 10, and 12. This is the parts of the file. The last piece will have a null pointer according to our linked list allocation scheme. So the last block has a null pointer which indicates that there are no more blocks to follow. So if in the last entry in our file table we will place a -1 for the pointer to indicate there are no more blocks to follow. So let's say the file A is taken at this block number 4. So this is where it starts, 4, and in the table, so this is the physical disk block, and in the table for block 4 we have entered the number of the block which follows. So after 4 comes block number 7. So this is the second piece of our file. Block number 7 in the table we have listed the next block number 2. This is the third piece of our file. And in the entry for 2 we have 10. That's the fourth piece. In the entry for 10 we have 12. That's the fifth and the last piece. So for 12 we have a -1 which indicates the end of the file. And this is all for file A. For file B we have the same situation. So let's say the file B starts at block 6, then 3, 11, and 14 is the last block, so in the 14 we will have a -1. So the file B starts at blocks, physical block 6. For 6 in the table we have entered 3, that's the next block to follow. For 3 we have 11, that's the next block. For 11 we have 14, 14 is the next block. And the last, so 14 we have -1 indicating that's where the file ends. So we could load this kind of table in the RAM to speed up the accessing of disk blocks, so we don't have to go to disk every time we need to read the next pointer for the next file. So this kind of table in memory is called the file allocation table. Or FAT. Remember when we said that the earlier version of Windows was using FAT16 type of file system or partition, and then it was using FAT32, and then it started using the new technology file system, type of file system. So why did it stop using these file allocation tables? So the random access is fast much faster. We're still following a chain. If the whole chain is loaded in memory, it's good. We can get to all the blocks of the file fast. But if it's not, why would it not be? How much RAM do we have? Let's think of the 32-bit computer. How much RAM can it have? FAT32. What does it mean, 32-bit computer? We have already talked about this. Yes, what is it? So the registers of the CPU are 32 bits. Very good. So the CPU is computing 32-bit addresses, right? It adds and subtracts them, multiplies them, 32-bit numbers together. And it's also the addresses, right? The addresses of the memory are 32 bits long, right? The physical addresses, each memory location has an address, right? The size of the address is 32 bits. That's what we mean by 32-bit computers. So, how many memory locations can we address with the 32 bits? You guys already answered this question before. How many unique combinations of 32 bits exist?
2 to the 32.
2 to the power of 32, which is equal to 4 gigabytes. 4 gigabytes of RAM. We cannot physically address any more RAM with 32 bits computers. That's why we couldn't add more than 4 gig of RAM following normal procedures, unless we had some software extensions and other things. So we have a fixed amount of RAM, and we're loading this table in the RAM, taking up even more of our RAM. What if the disk is huge? What if the disk is like, I don't know how many petabytes? Then what? How big is that table gonna get into the RAM? Can it take up the whole RAM? And there's no space to load the pages for the process to run? And so this method doesn't scale very well. If we start getting large disks with many files, and if we have to keep this table in the RAM all the time, then it's going to take up our RAM. Now with 64-bit computers, we might have more and more RAM, because you can address a lot more RAM in 32-bit than a 32-bit address, but still, we don't want this huge table taking up our RAM. So, this only happens if the size of the hard drive is huge and we have too many files on it. Now, if it's normal sizes, then we wouldn't have an issue, but we all the time keep getting bigger and bigger disks and storing more files on them. So we need to be mindful of that. This method does not scale well to large disks. Windows was using this method. Unix was using a different method called iNodes. Which is short for index node. So associated with each file is a data structure called index node. This index node lists the attributes and the addresses of the disk blocks which comprise the current file. So it lists attributes and addresses of the file's blocks.